triangles. We're going to be solving right triangles. If you have a right triangle, there are a couple of things you need to have. One, you need to talk about the Pythagorean theorems. Well, before I get carried away any longer, this is the standard way that you draw a right triangle. A vertices A, B, and C. C is the right angle, and side lengths A, B, and C. The side lengths are opposite. Notice the vertices are all in capitals, and the side lengths are all in lowercase, and they're always opposite each other. Okay? Side A is opposite angle A, side B is opposite angle B, side C is opposite angle C. So C is always the right angle. That means side C is always the hypotenuse. Okay? Now, there are a couple of things we need to know for right triangle trig that will give you everything you need, or sorry, for right triangles. Two things you need to know to be able to use. One, the Pythagorean theorem, a squared plus b squared equals c squared. And it's not always the two numbers you have squared equals the number you don't have. The only time that that is true is if the thing you were looking for is the hypotenuse. If you're missing one of the two legs, and yes, triangles have legs, if you're missing one of the two legs, you're not going to add the two numbers squared and then take the square root. That is the most common error students make. Okay, and then the other thing you need to know is you need to remember your right triangle trigonometry. Okay. The sine of angle A. It is important which angle you talk about, whether it's angle A or angle B. Side of angle A is A over C. The cosine of angle A is B over C, because that's the adjacent over the hypotenuse. And then the tangent of angle A is A over B. If you were talking about angle B, the sine of B is B over C. The cosine of B is A over C. And then the tangent of B is B over A. And you need to know those things to be able to solve. If you know those things and you have a right triangle, if you have a right triangle, which means you have 90-degree angle, and you have one side and anything else, you can find all the rest of the parts. If you have one side, you have to have at least one side of the triangle. If you have one side of the triangle and any one of the other remaining parts, you can find everything else. You need one side and something else, whether it's another angle, or one of the two non-90-degree angles, or whether it's one of the other remaining sides. But if you have one side and something else, you can find everything else. The nice thing about right triangles, it's very easy to do that. Okay? So, example number 1. Find the missing parts. Okay? And you can do them in any order. And it says round to the nearest tenth. Generally speaking, with angles, you round it to the nearest tenth. With sides, it's usually 2 decimal places, but I'll take 1 or 2 on these. I always start with the easiest thing first. And I have a right triangle. If one of my angles is 40, the other acute angle, these two angles here have to add up to 90 degrees. So angle B is 90 minus 40. It's a very easy thing to find. Find whatever you can that's easy enough to do. So B is 50 degrees. Now from there, start setting up your trig, because that's the only thing you can do from here. Okay. In order to do the Pythagorean theorem, you have to have 2 sides. We don't have 2 sides, we've only got 1, but your right triangle trig will give you that. So you pick an angle. Here's what I like to do. When I'm setting up, I like to use the angles that are given to me. I always prefer to use given information rather than found information. Doesn't matter much with the angles that are going on here because they're simple angles. It's one of them's given, the other one's just 90 minus that. It's straightforward. If I had used trig to find the angles, I wouldn't necessarily want to do that. But to find the sides, I like to use found information. That's my preference. So let's say I want to find, I'm going to use the 40-degree angle here. In order to find side C, I'm going to use the cosine. Cosine of 40 degrees is equal to 2 over C. Set up your trig ratio first. Don't try to do any solving. Don't do anything else. Set the ratio up. Set up the fraction. Cosine, sine, whatever of the angle is equal to this side over this side. Just write it down and then solve. Okay. Now to solve this is actually very easy. If what I'm looking for is in the denominator, just swap the trig function for what's in the denominator. C equals 2 divided by the cosine of 40. Listen. And then you pull out your calculator, and you end up getting C is 2.6. Two divided by the cosine of 40. 2.6. So now I have that part and that part. So I have one more to go. Yes?
So you only want to go out to
You know, I'm only going one. That's what it's asking for at this point. I'm just going to round it off to one. I know on some of my notes I have 2 decimal places. On some of my notes I have 1 decimal place. Really, if you call for it out to one is accurate enough. Okay. Now, I have choices. Because I now have 2 sides, 2 angles. I'm looking for the third side. I could easily set up the Pythagorean theorem and do that. I could set up another trig function and do that. I do have choices on the test. I really wouldn't care, just as long as you find the next side correctly. For me, I prefer trig functions. I don't know why, I just do. Okay. It's also good practice to set them up, because I think in some ways they're more difficult. But for me, what I do is I'd still use the found angle of 40 degrees, or given one of 40 degrees, and the given side of 2, and set up the tangent. Tangent of 40 degrees is equal to the opposite over the adjacent, so that would be A over 2. Multiply both sides by 2. A equals 2 times the tangent of 40 degrees. And you use your calculator. No need to go old school and dig out a table of values. Then A is 1.7. Question? Yes? That's just a typo. Is it really called a typo? I mean, when you miswrite something, it's an arrow. Yeah, there you go. It's a write-up. Yeah, it's just a write-up. Okay. Questions on that first one? Second one. I'm given 2 sides. I need to find the 2 angles, and I need to find the third side. First thing I would do, Pythagorean theorem, find the third side. In this case, it is the hypotenuse. So in this case, 2 squared plus 3 squared is equal to C squared. So 4 plus 9 is 13. C equals C square root of 13. And I have it exact in my notes. If you wanted to make it a decimal, it would be about 3.4, 2.5, I'm guessing. 3.6, yeah, not too far off. But you can leave it that way. I'd take that. I prefer exact values over decimals. It works for me. I like to use it, or I'm just going to leave it. Okay, now comes the next part, trying to find an angle. Okay. Still use your trig ratios. Still use your trig ratios. Now, I'm going to look for either angle A or angle B. On this one, I've got A is what I'm looking for in my notes. B could work the same way. Angle A, my found, or I should say my given information are those two sides, not the hypotenuse. Which trig function doesn't use the hypotenuse? The tangent does. So that means the tangent of angle A is equal to 3 over 2. Right? Set up your ratio first. Always just set that ratio up. Doesn't matter what you're solving for, set the ratio up. Write the ratio out first. Tangent of the angle is equal to this over this. Sine of the angle is equal to this over this. Just do that. Don't try to solve. Don't do anything else. Set that up first. Now, when you're looking for the angle, rather than one of the sides, you need to use your inverse trig functions. If I have the tangent of an angle is equal to that, that means the inverse, sorry. Go away, I don't want you. That means angle A is equal to the inverse tangent of 3 over 2. When you put that into your calculator, make sure to either take 3 over 2 and write it as 1.5, so you're doing the inverse tangent of 1.5, or use parentheses. If you type in the inverse tangent of 3 divided by 2, it will take the inverse tangent of 3 and then divide that by 2. If you do not put parentheses around the 3 over 2, because it will follow order of operations, which say, oh, I do the tangent, then I divide. And you get angle A is equal to 56.3 degrees. Make sure you get the right angle on this. Know how to do it on your calculator. How can I find angle B? Not, well, I can do 180 minus 90 minus that, but I could just do, because there's the two acute angles, 90 minus 56.3, that's the easy way. You could set up a trig function and do that if you wanted to. I wouldn't. B equals 90 minus 56.3, and that would give you 33.7 degrees. Piece of cake. Question. Okay. This chapter is all about triangles. This chapter actually has some pretty good real-world applications. Now, granted, they're kind of, you know, when you get them out of a book or something like that, they're kind of made to fit. But there are some really good, strong real-world applications that we will have in this chapter, stuff that actually is used, okay, in the real world by people. We'll talk more about this as we go along. This is one of the things I do like about this chapter. It has things that you can do that will work, that will figure stuff out, some of which are still currently used by a lot of people. Surveyors use a lot of triangle stuff. Okay, you're trying to find out how tall something is, how far away something is. This stuff works actually very well. Okay? So, a tourist at the top of the Gateway Arch, height 630 feet, in St. Louis, Missouri, observes boat A moored on the Illinois side of the Mississippi River. That's an I-L, Illinois, capital I, lowercase l. 2,070 feet directly across from the arch. She also observes boat B moored on the Missouri side. Given that angle A is 39.4 degrees, estimate the width of the Mississippi River at the St. Louis waterfront. In other words, how far apart are A and B? A is on one side of the river, B is on the other. How far apart are the two boats? That's essentially what you're being asked. Okay, it's actually not too bad. I have right triangles. I have a right triangle. I have a couple of right triangles. I have this big right triangle, and I have this smaller right triangle inside. Now, I know this angle here, that one was given to me, that's 39.4 degrees, but that's just for this small part here. Okay. What I'm looking for is I'm looking for this distance between here and here. If I can figure out this distance and subtract it from the whole length, I'm good to go. That's what I need to do. But I can't get that distance directly. Not from the information I have. I need to kind of find that distance in a roundabout way. What I need to do first is I need to look at the big triangle. And I need to find this big full angle across the top. I need to find this full angle here. Because if I find that, then I can find the other half. I can find the other part of that. Because I know what part of it is. I can find the other part here and use that to find the smaller triangle. Okay, so I want to find this one here. I'm going to call it theta, just temporarily, because I like to call angles theta. Which of my three trig functions do not use the hypotenuse? The tangent. So that's what I'm going to set up. Set up a tangent. Tangent of theta is equal to 2070 over 630. Theta equals the inverse tangent of 2070 over 630. And I get 73.1 degrees. So let's clean up some of this crap off here. So this is 73.1. This is 39.4. I'm going to call this B beta. That's the other angle I like to call. Doesn't really matter. That's easy. 73.1 minus, what was it, 39.4. The angle I found minus the inside angle I was given. .7 degrees. So, do you know where I am now? Have you followed along what I've done so far? Yes. Take the big triangle, found the angle here, subtracted what I had up here to find for the small triangle. And now I can find that length there from the small triangle. I can figure out what this length here is on the small triangle now. So the trig function. Once again, this would be a tangent because it doesn't involve a hypotenuse. So the tangent of 33.7 equals x over 630. X equals 630 times the tangent of 33.7 degrees. X is, what did I get, 420 feet. Rounding it off. Because that's really about as accurate as it can actually be, right? Did that answer my question? No, what do I need to do? Subtract that from the 2070. And you get 1,650 feet. So it's about a third of a mile. It's a pretty good wide river. Anybody here seen the Mississippi? I did when I was about your age. A couple of times, drove over it 2 or 3 times. Questions? Okay. A person observes a lamppost with an angle of elevation of 12 degrees to the top of the lamp and an angle of depression, which is not sadness, to the bottom of the lamp. The eye level is 152 centimeters. How far away is he and how tall is the lamp post? So here's what we're dealing with. Angle of elevation up from the horizontal. So if you look straight out, there's no elevation or depression. You look up from there, that's an angle of elevation. So he look up to the top of the lamp, he's got to look up 12 degrees to get to the top of the lamp. Come on. There we go. To get to the angle of depression, when you're depressed, you're always looking down, right? So you're looking down, that's an angle of depression. So instead of straight out, he looks down 7 degrees to get to the bottom of it. Okay. That's our given information. And we have one other piece of given information. If eye level is 152 centimeters, that means this distance here is 152. So that height of the lamppost is part of the height of the lamppost. And it's not equally divided either. It would be equally divided if the angle of elevation and the angle of depression were the same. They're not the same. It's not equally divided. Now, our question asks us 2 things. Our question asks us, how far away is he? What's that length there? And our question asks us, what is that height overall? Okay, so we have to solve two different equations. We got to figure out x, and then once we figure out x, we can figure out y, and then add that to 152. I find it easy to break things down into parts. Instead of looking at the whole picture, now you want to have the big picture in mind the whole time. But when you're working the problem, break it down into parts. I have this smaller triangle. I can find the distance, how far away he is, by just using that smaller triangle. Okay, once again, this is a tangent. You will find yourself using the tangent an awful lot in these types of problems. Tangent of 7 degrees is equal to 152 over x, which means x, my distance out, is equal to 152 over the tangent of 7 degrees. So he is, what did I get? 7.9 centimeters away. So far, so good. Now I have to do the same thing with the upper triangle. Set that up. You good? So break it down, set up the other triangle, find my height, find my y, which will not give me my full height, but it will give me the other part that I need. And I do the same thing. I set up a tangent. Tangent of 12 degrees is equal to y over 1237.9. So y equals 1237.9 times the tangent of 12 degrees. So my height y is 263.1 degrees. So this part here is 263.1, sorry, centimeters, not degrees, centimeters. Does that answer my question? What do I need to do? Add the two together. So my height, add those two together and you get 415.1 centimeters. And then we did the distance, that was the distance away, that was the other one we were looking for. Questions? Awesome. All right. Find theta. Okay. So what do you want to do first? Draw a horizontal, because if I'm looking for theta, if I draw in a horizontal line, then instead of theta, if I call this angle y, theta equals 2 times y. So I can solve for y and go from there. Now, I don't have enough information to solve for y by itself. I do, however, have two triangles equal to that share the same angle measurements, because they both have a right angle that they share, and they both have this angle down here that they share. So let me put the numbers back in that just got put over. So that's 2, and that's the 4 there. So I can set up trig ratios. I can set up trig ratios to solve for y. Can't quite do it directly, though. I need to do some more labeling. Okay. Let's call this length here from here to here, call that x. So in this pink triangle, that's 2. This is x plus 2, and that's y. Because this whole length here, this length from here to here is x. This length here to here is 2, so it's the whole length, x plus 2. Because it tells you, if you look at your diagram, what's the radius of the circle. And then we have a second triangle. Same setup. What's the radius of my bigger circle? 4. So this length here is 4. How long is this side here going to be? X plus 8. Because how long is it from here to here? 2. How long is it from here to here? 2. How long from there to there? It's 4. So x plus 2 plus 2 plus 4 gives me x plus 8. Yes? I just took the angle and divided it in half and called the half of it y. Because if you remember your if you remember your geometry, an angle, I forgot the name of that angle. The one that comes and touches the two sides of a circle like that. The line from the angle to the center bisects that angle at the top. It's one of the things you get. Now, it looks like I'm not getting anywhere near my angle, am I? Set up a sine function for y for each triangle. You need both of them, and you'll see why here in a second. So, first one, sine of y. The sine of y is equal to 2 over x plus 2. And in the second triangle, the sine of y is equal to 4 over x plus 8. Do you see where I'm headed on this one? The sine of y and the sine of y are equal to two things, which means those two things are equal to each other. 2 over x plus 2 is equal to 4 over x plus 8. Because the sine of y is equal to those two things. And the sine of y, if one thing is equal to something else, to two things, those two things are equal. It's called the transitive property. If A equals B and A equals C, then B equals C. Solve for x. Cross multiply. Yeah. So what did that get us, I hear you asking? Give us x, which means that we now have two sides. Because if x is 6, x is 4, my bad, 4. If this is 4, we can now set up the trig function to the sine for this angle. The sine of y is equal to 2 over 6. And what is 2 over 6? 1/3. So that means y equals the inverse sine of 1/3. So y equals 19.5 degrees. That's what I got, 19.5. Yeah. Did that give me my answer? No, because what I need is theta, which is 2 times that, which is 39 degrees. Questions? Okay, when you're working these problems, break them down into parts. Take triangles, draw triangles, label the triangles, solve for the parts of the triangles you have. Figure out what you know, figure out what you don't know. Don't try to do the whole thing all at once. Break it into parts. It's a lot easier. Yes. Sine of y equals that, sine of y equals that. They equal the same, they're equal to each other. These two things these are both equal to the sine of y, they're equal to each other. And then Cross multiply to solve.